let's take a quick peek at 8 and see what that is. Because we're getting higher up in the days, and we might end up getting tougher and tougher problems now. So getting a little nervous about doing multiple entries per day or per stream. But let's see. You come across a door implementing what you can only assume is an implementation of two-factor authentication after a long game of requirements telephone. Okay, I was just looking at the links. To get past the door, you first swipe a keycard. No problem. There was one on a nearby desk. Then it displays a code on a little screen. Tiny LCD. Okay. And then you type that code on the keypad. And then presumably the door unlocks. Unfortunately, the screen has been smashed. After a few minutes, you've taken everything apart and figured out how it works. Now you just have to work out what the screen would have displayed. Magnetic strip on the card you swiped encodes a series of instructions for the screen. These instructions are your puzzle input. The screen is 50 wide by 6 high. By 6 tall, sorry. All of which start off and is capable of 3 somewhat peculiar operations. Rect A by B turns on all of the pixels in a rectangle at the top left of the screen, which is A wide and B tall. Rotate row Y equals A by B. Shifts all the pixels in row A right by B pixels. Pixels that would fall off the right end appear at the left end of the row. Rotate column X equals A by B. Shifts all the pixels in column A down by B pixels. Pixels that would fall off the bottom appear at the top. Okay, let's take a look at what the input looks like. Get input 2016 8. 153 instructions. All right, let's take a look at them. So there's a rect, there's a rotate row Y, rotate column X. So we have a bit of redundant information here, but that's fine. Do we have any like vastly huge numbers? Nothing stands out. All right, this doesn't seem too hard, at least part 1. All we're going to do is follow the instructions, and then it says how many pixels should be lit at the end. And we can just type that number in. So we can start guessing, or we could try to solve it. Let's do the latter. Git status. Git add input. Git commit -m 2016 day 8 input. There we go, and mod here. Let's grab 8. Oops, 8 like that, 8 like that, and then day 8. Grab this. Oops, I didn't want to do that. 2016, day 8. Okay, so the first thing we're going to do is parse the instructions into actual instructions, which means we need like a little instruction struct, enum. Rect of x by y. We have a column rotation of which column? I guess that all these should be U-sizes, right? Because we're going to index into something. U-size, U-size. And then we have row, U-size, U-size. And the way this works is it's going to be x by x, A by B, rectangle. It's going to be rotate column A by B and rotate row A by B. All right, just for my sanity. And then we can just create a parser for it. Impl, oh, I didn't even give it a name. Inst instruction. New, and it's going to take in a string, and it's going to return a self, and that's going to do a, now we have to actually decode the instruction. So head input 2016-08 text. So this is what it looks like. And then another one, this will be like column X. So we just need to look at the first word. Should we just split it into words and then collect everything? I think that'll work. Oh, we can split first. Yeah, we can look at the first word, and if it's a rect, then we know what to do with the rest of it. Let command, and the rest is equal to s dot split once on space. Let's do that so we can actually compile and take a look. That should be a string and a string. So let me say match command, and it's going to be rect, which means we're going to take the rest and we're going to split it into two numbers. Let AB is equal to rest.split once on X, unwrap, and then return self rect, and this is going to be a.parse b.parse, unwrap. And then it closes, and then we'll just do this for now, panic invalid input. And I'll fix that in a minute. But this should build. Oh. Yeah, I mean it builds, but does this help remove return? Oh, because the match command is returning. Yeah. Okay, that makes sense. Okay, and then for rotate, what are we going to do? We're going to check to see if the next word is row or column. Actually, what I want to do is split once by equal sign. So let, what should we call this? Row call, RC, comma, amount is equal to rest.split once on equal. And then we're going to see either the word row or column. So if rc.starts with row, oh, we can actually do the x by y right away. Let a comma b equals amount dot split once by unwrap. And then we're going to say let a be a u size and b u size equal a dot parse unwrap, b dot parse unwrap. And if it's a row, then we're going to return self row AB. And if it's a column, then we'll just return self column AB. Okay, and then we can see if that actually works. Cargo clean. Can't we define the type inside? Oh, we not like this, right? We have to actually say it like this. Colon u size. There. Okay, that works. So now what we should just do is parse out the entries and print them to see if we got something valid. So for line in AOC lib, read lines, input slash 2016-08.text, println, let's have debug output for this, debug, derive, debug. So println this of instruction new line. Okay, and if we run it, we have to rebuild it. All right, give it a second. All right. I have no idea if that's correct, but we can take a look at the input. 2016-08.text. Nick Vorsa says, that's a nice parsing implementation to learn. It's something it's kind of a hack, but it does the trick. One of the ways that people solve these kind of things is just to write a regexp and have the regexp pull out all the values you need. So if you're writing it like in Python or something, that's what I would recommend. All right, so these look like these match up. I see column 32, 23, 13 by 1. There's a row 06. So these seem to be doing the trick. If I page down here, yeah, all these look right. Let's just make sure we got the last one in there. Rotate column X by 4. Yeah, so we're not clipping off the last one. That's good. I do see 47, 46, 55, all these guys here. All these columns get rotated by 5 and so on. All right, so I think we have all the instructions. Now we just have to implement everything. We did the easy part. Let's do the hard part. The hard part is basically just creating the grid and then turning things on and off. And following the instructions. So we can just say, we're going to store the instructions in here. Inst is a vec of instructions. And here, all we're going to do is say self.inst.push that. And that didn't work because I left an F there. I just want to make sure this is correct. Nope. I messed something up. Oh, I have too many closing braces here. Probably, yeah. Missing inst, of course we are. There, okay. So we just need now to step through each one of the, for I in self inst, and just force things to happen. So I think, so the standard way to do stuff in these things is just create a hash map, which maps the on pixels. So we can do that. Use standard collections hash map. So that makes the rect command very easy, right? We have A by B, and all this is going to do is go for each entry in the hash map. Let hash map equals hash map new. Oh, hash set, because it's either on or off. So it's either present in the set or not present in the set. Nick Vorsa says, pack them in a U64. Yeah, so let's make it as complicated as possible. Yeah, you know, if memory was a concern, that is definitely the way to go, right? Because then what you do is for every A and B, you just calculate the index of the U64 that you want, plus the bit within that U64 that you want, and then turn it on or off. I don't think that we're going to have a problem here because it's, like I said, it's only 2,000 instructions, right? That's all we had when I got the input. Oh no, 153 instructions. So it's going to go super fast, no matter how poorly we implement it. Turning on each entry just says for row in, and this is all the pixels in a rectangle at the top left of the screen, which is A wide and B tall. Oh, okay, so it's the top left of the screen. So we're not even getting the, so row to A, no, row to B, B tall, and for column in 0 dot dot A. All right, I should say that here, right? Col and row. That way we're not flipping around our things. And all we're going to do is say HM insert, or H, it's a hash set now, so we can say hash set insert RC. Oh, we have to do a match first. Match I. There we go. And now in instruction column, call and amount. And then this is going to do nothing for now, because I just wanted to get this thing to compile, and row. And then all we care about, I guess we can do that. All we care about at the end is how many are set. So we can say hs.len. So if we don't follow the column and row commands, we only get 29 pixels set. But that's fine. So let's do column and row now. Should we do test using this test input and just to see? I think we should. So we can comment this out, this line out here, and we can just generate, oops, for I in test input. I'll do that. And then our test input is just going to be these 1, 2, 3, 4 instructions. And we'll push those in. Let test input equals vec new test input. And that way we can see, is there 1, 2, 3, 4, 5, 6 pixels set. I guess we never changed the number of pixels, but we can at least print them out and see what they look like. Dot push instruction new, and we'll just do rect 3x2. And then we have 2, 3, and 4. Rotate column x equals 1 by 1. Rotate row y equals 0 by 4. And then we have rotate column x equals 1 by 1. And then I can just print out the hash map and see if it looks right. Println, sorry, hash set. And we can just look at the numbers and see if they're all correct. Right, so we have 1, 1, 1, 2, 1. You're right, because we haven't done any rotations yet. So let's do that. Let's figure out column. And this should be row, obviously. So for given column C, we're going to find every entry in the hash map and remove it. Okay, so here's what we're going to do is we're going to say for RC in HS iter. Because what we do is we're creating a new hash map. Let mod new hash, sorry, hash set equals hash set new. So now these should be all the rows and columns. They're ampersand U size, but we'll fix that with a star. If C is equal to the column that we're shifting, then we want to add amount mod the height, 6 pixels tall. Then new HS dot insert, same row. Oh wait, if we're shifting column, we're modifying the row that it's on. Koopa 1338 says into iter for avoiding star in iterations. Yeah, and that's a good point, because we don't need HS anymore because we're going to reassign it with the new HS. So let's try that. Thank you. Yep, I32, I32. Perfect. So now we don't need that. So this is going to be R plus amount mod 8, but the same column. Otherwise, we leave it alone. New HS dot insert RC. RC. And then after that loop's over, we say HS equals new HS. And let's see what blows up. Oh, because call is ampersand. Can I do that here? Nope, I can't do that. That's a shame. So I can just say that like that. A Muscatique 97, thank you for the follow. Very much appreciated. Oh, Negvorsa points out that I should be doing 3, because this is what is this? 3, 6. This is a 7 by 3 instead of a. Yeah, so for the test purposes, our row should be mod 3 for 0, 1, and 2. Okay. And then the columns are going to be different. So did anything shift? It looks like maybe something shifted. Maybe we should print that out after each instruction. We should dump it and see what the instruction was. Rect row call row converts to that, and then this is a column call amount, and then we do the same thing for row. It's the same code, except we care about the opposite things. If row is equal to row, then we can insert column amount mod, oh, what was it? 7. And row at the beginning here. And then this becomes row and row. All right, let's see what happens. So rect 3 by 2 sets 0, 0, 0, 1, 0, 2, 1, 1, 1, 0, and 1, 2. Yeah, it doesn't have to be in the same order, right? Then if we rotate column 1 by 1, are we getting these values here? We should have a 0, 0, so it should be 0, there should be a 0, 2. There is. There should be a 1, 0, 1, 1, and 1, 2. 1, 0, 1, 1, and 1, 2 right here. And then there should be a 2, 1. And there is. Okay, so that rotation worked. Then we have row 0 rotating by 4. which should result in 0, 1, 2, 3, 4, and 6. So 0, 4, and 0, 6 are right there. Then we have 1, 0, 1, 1, and 1, 2 again. I see them. And a 2, 1. And we rotate this column by 1. So we should have a 0, 1, a 0, 4, and a 0, 6. There's a 0, 1, there's a 0, 4, and there's a 0, 6. And then we should have a 1, 0, and a 1, 3. Sorry, 1, 2. 1, 0, and a 1, 2. There's a 1, 2, and a 1, 0. And then the 2, 1. Okay. So for the very simple example, it's working. Let's get rid of these print lines and try it on the actual data. We have to change the size. All right, what was it? It was 8 by 50. Wide and 6 pixels tall. Okay. Very good. So that should output the 6 things we have now, and let's flip it back to the non-test input. Let's put this up at the top and keep the test step together like that. Okay. We got 110. I guess that's a reasonable number. What's 50 times 6 is 250, right? So about half of them on. I guess that makes sense. Yeah, it is. It made sense. Okay, so we solved part 1. There we go. Let's. Is there any cleanup we can do? What does Clippy say? Does Clippy have any hints for us? It does. It says help consider using a macro. Oh. I guess we could do that. Kind of like that, like that, like that, and like that. Okay, and then still 110 because all we did was change that thing. Okay. So git status, git add source, git commit -m, 2016 day 8 part 1. All right, done. What's part 2? Part 2 is you notice that the screen is only capable of displaying capital letters in the font it uses. Each letter is 5 pixels wide and 6 tall. After you swipe your card, what code is the screen trying to display? 6 tall is how big our display is. 5 pixels wide means we could fit 10 characters across. Unless there's a gap between each one. I guess what we do is just print it out and see what it looks like. For part 2. Oh. Yeah, we need to return a vector of string. So what we can do is let mut answer equals vec new for r row in 0.6 for column in 0.50, and we'll just make a string. Let mut line equals to string if, oh, right, we need to save this. Okay. Answer hash set of I32, which means this is going to go to a second line. Oh well, answer hash set new. And then instead of this, we say self answer. Right? Okay, and then we say if self.answer.contains row column. And then we're going to do a line.push of hashtag else line.push of a dot. And at the end of the column, oh, I did it backwards. No, that's right. At the end of the column, I'm going to say answer.push line. And then create output answer. And it doesn't like that. Oh, these are U sizes. Okay. I thought I made everything U size, but I guess I didn't. When did I fail to make these U sizes? These are U sizes. That's a U size. Oh, these are U30. Okay. U size. My mistake. Nick Vorsa says new line. Yeah, right. If I were printing that out, you're exactly right. Typically the way this works is that you're doing a new line here. But I'm actually, in my test runner code, will automatically insert the new lines between each string for me. But answer should be a vec of string. And what is it actually? It's a vec of string. Okay, this is a problem because this was supposed to work great, and it's not working great because this is a vec string, and it's saying, oh, we can't output this as a display. I can't. That's a little frustrating. That's a little frustrating because let's take a look at my test runner. Right, pub trait runner has vec string. So when we run part 2, this was supposed to work. Print solution. Now it prints out the time. It says which part it is, and then here's where it puts the new lines. It's supposed to just display these things. And this is a vec of string. Why? Okay, I'm getting distracted from actually getting the answer, but I want to get my output correct. I can just print out the answer here instead and just say, oops, here. That was supposed to. Oh, create output's supposed to have it automatically. Okay, that's right. Let's jump to that because I think that's what's throwing us off here. Yeah, it's generating this. So all I need to actually do is just say answer, because that's already a vec of string. Oh, and this was moved. We can't do that. We have to do it. Can I do this? Nope. Because it should be okay that it's moved, because we're just going to reset it. All right, I guess we have to undo all that and then just change R and C to stars again. Oh, except oh, that's not, oh, here. There, and now we have to fix this one. Oh well. It would have been good. There's probably a way to fix it properly. But it should be okay. Oops. It almost worked. It almost worked. I need to fix the formatting though. Where is the runner? It's in main. I don't have enough spacing over here. It looks like I have to add. So we have 3, 4, 5, 6, 7, 8, 12, 13, 14, 15, 16. So we need 16 spaces. Oh, I didn't have the insert. You know what I can do is this, right? 16, like that. And just say, quote, quote. There. Okay. So I think we can kind of read this, right? This looks like a Z, J, H, R, K, C, P, L, Y, J. Oh, I guess we got to do it this way. Put that there, move this over here, and then I got to type it in. All right. Z, J, H, R, K, C, P, L, Y, J. It can't be wrong, right? After all that, if it's actually legible, after all those rotations, that has to be the right answer. Okay, very good. Here we go. So we did 7 and 8 today, and now I got to end the stream. Let's see what Clippy says. Clippy's happy. That makes me happy. Git status, git commit-am 2016, day 8, part 2. And everything checks. All right. Well, thank you everyone for hanging out with me. Hope you have a great rest of your day.